All right. Hey there, everyone joining in. I'm James Daniels. I'm with the Firebase team. Um, I'm here today to talk to you about some of the improvements that we've been making to AngularFire. We have Google Analytics integration now. We have deployment schematics and a lot of cool things. Uh, yeah, as mentioned, I'm on the Firebase team. You might be able to tell from my t-shirt as well. Rocking the brands. So I'm developer relations. My primary responsibility, uh, you know, presumably a lot of you are Angular developers. My primary responsibility is actually maintaining the AngularFire repository, which is the bridge between Angular and Firebase. And I work on cloud functions and documentation. And I normally do a lot of events. It's been a little interesting in these turbulent times to switch from work from home. I'm actually presenting from my guest bedroom in a cottage in Maine. I decided to get out of the city and let things calm down a little bit. But thank you so much for, joining the live stream. And then if you're watching this recorded presentation later, thank you so much for joining. So Firebase, if you're not familiar with it, is Google's application development platform. Our mission is to help you, app developers, succeed, build your applications faster, stronger, leaner, right? We want you to be able to do more with less resources. And that's, sadly, that's a very important thing these days is doing more with less. So 2 million applications use us, probably a little bit more since this number was last approved by legal. But here's a couple of the companies that have approved to be on this slide. I'm sure some of them are using Angular. I haven't really dug in to see, but definitely a lot of apps are using Angular. So we have tools for the entire life cycle of development, right? Namely, first and foremost, is the develop suite of tools, right? We have data authentication. This is real-time database, Firestore, tools like that that you might be familiar with. Backend compute in the terms of Cloud Function, and then abilities to run test labs and stuff like that. That's basically what you're going to be most familiar with as a web developer. But for mobile developers, we've had a lot more, right? We have release management tools, analytics, crash reporting, when you're running your application. And when you're engaging with your users, we have cloud messaging, we have remote config to be able to personalize things, and an A/B testing for experimentation, right? So Firebase has tools built on top of Google Cloud that contain this whole life cycle, right? It's multi-platform, so we have iOS, Android. We also have the web. We have C++ and Unity. Of course, most of you here are interested in the web pieces, though not discounting the fact that you do native application development. And if you've used Firebase in the past, you might have seen all these tools and only about a third of them were available on the web. This is something that's been improving since Google I/O last year and FireConf last year as well. So recently, we've added remote configuration support, Google Analytics performance monitoring, emulators, and more. Remote configuration, if you're not familiar with the product, is a tool that allows you to configure your applications at scale without redeploying them. So think of it kind of like a JSON endpoint that you can hit that has, local store backup. The really nice thing here is that remote configuration can scale to billions of consumers, right? This is a very robust tool, and it allows you to then go and change these configuration toggles. A lot of people use this for feature gating or A/B testing. So you could have a feature flag saying enable X feature or variant A, B, or C on remote configuration. You can then change that based off, say, a Google Analytics audience. So Google Analytics, what does Firebase bring to the table? So there's been a confusing history of Google Analytics for Firebase, Firebase Analytics, Google Analytics Gold, and all kinds of complex stuff. It's all branding. My coworker Todd on the Firebase team actually has a really great and kind of sarcastic blog post on how the Google Analytics messaging is complicated. But basically, Google Analytics for Firebase is a rebuild of Google Analytics, really meant for native applications. It does automatic screen tracking, stuff like that. And we've since brought that to the web. Now, AngularFire, which I'll touch on in a little bit, actually brings a little bit to the table here and has automatic integrations between Google Analytics and the Angular router. Performance monitoring allows you to be able to look at the performance of your application in the real world, see endpoints, what might be slowing down your application. And feedback that we've always gotten is it's very hard to develop Firebase when you're, say, on an airplane or in a low internet connectivity environment, because Firebase is a cloud service, right? So the past 6 months have seen a lot more support for emulators. So you can do a lot of that development locally. So, I've mentioned AngularFire a couple of times. Presumably, some of you have worked with it. At least if you worked with Firebase, you can find us on GitHub here. We recently just released version 6. There are some rough corners here that I'm chiseling down now and really hoping to get AngularFire 6.0.1 out the door. So if you see any issues, just let me know. We're working on that, smoothing out those rough edges now, and are aiming for an update really quick. So ultimately, what do we bring to the table, right? We're the official integration between Angular and Firebase. So first, we have Google Analytics integration, right? We have this deep integration that I'm going to talk to you today about. We can alter the behavior of your application with remote configuration. And I'm going to touch on universal deployment schematics. And I'm going to get into a little bit of how I did this, right? AngularFire is a very small team. We got a couple DevRel people. We don't have a lot of software engineer support. I want to talk a little bit about how we made Firebase, which is, agnostic to any framework, how we made that work really well with Angular. So I'm going to jump into a little bit of code and show you what I've been up to. So what I've got here actually is a new kitchen sink application that I've been building in the AngularFire repo. You can actually find this on our GitHub. And I'm going to walk a little bit through what I'm doing and highlight some of the new capabilities here. I have this running locally. I say that, and then I already have that port in use. Pardon me. Let's start this up again, now that I'm not running something else on that port. So while that's starting up, I'll walk through some of the new stuff here. There's a lot of things. I'm basically pulling in all the different modules. So these are the modules that are going to set up basically everything for dependency injection and configuration. So I'm bringing in the whole kitchen sink, every one of them, right? The ones I really want to highlight are the AngularFire Analytics module. This is that integration with Google Analytics. We also have remote config is new, performance monitoring is new. And I get this question a lot for AngularFire is how do I do things like hook up to the emulators or do advanced configuration? And these are where our dependency injection tokens come in, right? So here I'm actually telling Google Analytics to be in debug mode if Angular's in dev mode. I configure my database URL and I can point towards an emulator if, I mark this should use emulator factory. I can override the Firestore settings, cloud functions, all these point at the emulator. And remote config, I can actually decrease the aggressiveness of the cache. This is especially great, again, for dev mode. So when I'm actually playing around with remote config, I want to see those values updated very quickly. Whereas our end users, it's typically a default, I think, is a 24-hour cache. So that's part of the reason why remote config scales, right? It's a JSON endpoint, very aggressive caching. I can override that, though. So we have advanced configuration here with dependency injection. Now, for the analytics, if I want Google Analytics integration with my Angular app, all I need to do is pull in the screen tracking service here. That's just exported by AngularFire Analytics. And then, of course, I configure Firebase and put in my measurement ID. And you can see some of that in my environments. But that screen tracking service is actually going to immediately hook into the Angular router. If the Angular router is there, it will start monitoring router events. So it'll look at, activation end, activation start, navigation end, and it'll map all those events together, and then ultimately distill that into Google Analytics events. And here, let me actually show you what that looks like. To switch over to a different browser. So here, let's jump into this. So I'm going to choose one of my test applications. Let's go with on snapshot, since I know that has a lot of events. I'm going to go to my analytics dashboard. Analytics dashboard. And this is where I should put the warning about live demos. So let's jump this out to the last 12 months and see what our events look like. So you can see I did a lot of testing when I was first pushing out this feature. You can actually see here we have engagements, we have top screens, and this is where the magic of our integration comes from. So let's actually switch to screen view events. And this is this deep integration with the Angular router. So here I can see 151 events, 14 different users. The average count per user is 61. We can actually see here that I'm tracking the router outlet. So right now I just have one outlet, primary. But if I did have secondary outlets, say a side nav or a banner or things that navigated independently, those would be logged as well, and I can filter on those. The cool thing here is we automatically get screen class tracking and screen name. So screen name is actually going to be the route right here, so the route matching pattern. And then screen class is going to show us, which component was loaded. So article module, home component, home. Some of these will depend a little bit on how you're minifying for production. But one of the things I tried to do was choose stable identifiers, right? I don't want to pull a class name that's been minified. So I try to be a little smart about what I'm sending here. That's why the matching pattern is what's sent as screen name, right? Because I don't want to, send it across as M, capital T, D, or whatever Webpack has compressed things into. I want it to actually be something meaningful to you. Now, from all this, right, this is Google Analytics. We can get crazy. All this goes to BigQuery if we want to really drive into things. But basically, we have this really great integration with the Angular router to start with. Next, we have on this application our user tracking service. So user tracking service, similar to screen tracking, where if the user is actually using Firebase authentication, say they sign into the application using our authentication product, then they will automatically get their user identifier tracked along with the rest of the statistics. So those are very automatic. Let's talk a little bit about another automatic thing, which is performance module. So by bringing an AngularFire performance module, I'm automatically hooking up Firebase performance monitoring to the application. Further, I've enhanced it with this performance monitoring service, which will track Angular-specific statistics. Right now, I'm only tracking application stability. This is something that I'm investigating what traces automatically would be useful to Angular developers. So let's see what that looks like in this console. So if I navigate to performance, oh, it's on the iOS app. Let's switch to the web app. All right, here we go. So we have some performance data now. So you can actually see that, I can see the first contentful paint. I can see my onsnapshot.com, that's my production. And of course, this is me playing around with Cloud Run, so doing some universal stuff. So let's actually jump into my traces. And I can see my traces. So I have get article, get articles, on snapshot. I can navigate this on the page loads. I can jump right into this data, right? So I can see how long it's taking for first paint, first contentful paint, the very important first input delay, which you may need to polyfill, load end events, all these. So really great stuff. I can see the histograms. I can dive into these, look by browser, by country, stuff like that. You can actually see that this has an automatic outlier. It's letting me know that onsnapshot.com is very slow in the United Kingdom specifically. So if you see, everything else is doing pretty good, but United Kingdom's taking 4.6 seconds. That's something for me to investigate. Maybe I need to put, another endpoint for my Cloud Functions or my Cloud Run instance, or figure out something. But it looks like the United Kingdom is going very, very slow. Well, I'll need to investigate that, but really great that I can dive into that. I can look into page visibility, the URLs, browser, all that jazz, and dive into it. Let's go back here. I can also see a good map, world map. So if I actually jump to last 90 days, I'll probably see a little bit more. So you can see United Kingdom's a problem, and India is also a problem. India is very much a problem. But this is great for jumping into that data. I can also go to network here, and I can see the different API calls that my application is making. So I can see how long they're taking. It looks like probably the slowest here is Firestore. Now, this is a little deceiving. Need to work on this because Firestore is opening a socket connection, right? So this is actually never going to resolve. So maybe a little bit of an outlier here. I could definitely work on making that statistic tracking better. But I can see, I can look at this, whatever that endpoint is, that's probably an SSR or a Cloud Function. That looks to be a little slow, this user content. So it gives me a good idea of what's holding up the application. So this is all automatic, right? That's what's really great about this. Now, if I go back to my traces, now that I'm out 90 days, I can actually see my automatic, what is it? The automatic performance monitoring service logging an event. Interesting thing here is this is showing a problem with my application. The one thing I log by default is stable. If you do have ideas on other things that I should be tracking specifically for Angular applications, let me know. But I have is stable here, and there's only one sample for is stable, which is telling me that this application actually has Zone.js issues that I need to debug, which is bad news. Whereas get article and get articles have more samples. I should expect stability to have more than one sample, and it shouldn't take 4,000 seconds for my app to reach is stable. So really good tools here for seeing my application in production and figuring out what might be wrong with it. So those two are very, very automatic, right? So we have analytics, we have performance monitoring. Last thing I want to show you really quick is remote configuration. So let's actually jump into remote config here. So remote configuration, I can actually pull in as a DI service here. So I just pull in AngularFire remote config, my service is pulled in. And I made a number, in AngularFire, a number of convenience observables on top of the Firebase service. So here is actually remote config changes, piping, and then I have that trace operator, so I can actually see in AngularFire performance monitoring how long remote config is taking. But this is going to give me an observable of parameters. So since this should now be up and running, let's actually go to localhost 4200 and see it in use. So if you see, this is rendering everything, fetching everything from there, and now we have our remote config. going back to Firebase, if we go to remote config here, I can actually see all of these here, and I can actually configure them. I can, add parameters. I can create groups, right? So if I jump on this, I can change this value. I can add conditions. So this would be if I wanted to experiment with a group or, change it for a specific browser, right? So applies if. So I can use random percentage, user audience from Google Analytics, country, region, languages. And then that would go ahead and change this value here. Like I said, it's very aggressively cached. But let's go ahead and see if I can do some configuration on this. So first thing I'm going to do, just to test that this is, so right now it is 10 seconds. So I should have a 10-second cache. Let's go back here. And which one was I looking at? So we have our key yo, value what. Let me zoom in here. And we have our fetch time. And I'm actually in the wrong application. Let's go to here. There we go. That's why that didn't make sense. So there's our default value. I'm going to add a new condition that if the browser platform web and so platform web browser is, let's go with Chrome. I'm going to say hello Chrome, create condition. Update. So Chrome should be hello Chrome on yo. And let's go ahead and publish this. And again, this is where live demo warning comes in place. So let's hit refresh here. And it looks like we got live demoed. So maybe the caching's a little aggressive, or I clicked on something wrong here. Parameter, value Chrome. Oh, well, I'm going to move on. But the idea here is that would be able to update. I can target different browsers. I probably clicked a button wrong. All right, let's jump back to the slides. So after walking through some of those new features, if you've used AngularFire, give those a try. Let me know how it goes. Let's talk a little bit about how in version 6 I achieved this. So the Firebase JS SDK is platform agnostic, right? It's not meant for a specific framework. It's completely agnostic. So there's actually, it doesn't take into account Zone.js. One of the downsides is it's actually a prototypic inheritance. Like it has prototypical inheritance. It makes it a little bit big and hard to tree shake. This is something that the Firebase JS SDK is working on. But, in AngularFire, I have the opportunity to do a couple things to make the experience better for you, an Angular developer. So first and foremost, I've added dynamic imports. So say you pull in Firebase authentication, you want to integrate with Google. Right now, because it's that monolithic prototypical inheritance pattern, you have to pull in Facebook authentication, GitHub authentication, phone number authentication, email password. All of those bytes come with it. So to make the experience a little bit better for you, we're now using dynamic imports in AngularFire. So we await the import. Now, another downside of this prototypical inheritance pattern is there's a lot of side effects, right? So if you pull in the vanilla auth SDK for Firebase, you need to handle the Zone.js wrapping. In AngularFire, we're doing this for you. So we wrap the SDK and run outside of Angular. We isolate those side effects so they're not going to destabilize your zones. And then finally, to make your development easier, we're actually using ES proxies. So an ES proxy is a way to do some meta programming with JavaScript. So in AngularFire, we have a small team. We can't update our library every time the JS SDK changes, which is pretty much once a week. There's a new version of one of the JS SDKs. So we want to stay agile. So we actually ES proxy and promisify this dynamic import so that you, the Angular developer, can just code. It looks similar enough to the JS SDK vanilla that you can be functional and productive. We also have those convenience observables built on top. But whenever a new version of the JS SDK comes out, you won't have to wait for us to add support for dynamically importing this new function. It'll just come automatically. So let's talk a little bit about the ES proxy and how this code works, and maybe you can take some lessons here. So this is an ES proxy here. So we're setting up a new proxy. The way I've developed it doesn't matter what the base object is. But first and foremost, we're getting, right? So a proxy is going to wrap some object. In this case, it is the promise that is dynamically importing the SDK. So when we do a get here, well, this is actually called whenever we try to get access to a property or a function on that object. So if you pull in AngularFire auth and you call .signin, right? Let's talk about how that goes through this flow. So we first do a get. It's triggering a request for a property or a function. First, we look whether or not the SDK has that object. This is an SDK promise, right? So if we're just awaiting the SDK or something like that, which will be requesting the then method, we'll actually return that. Otherwise, we wrap a new proxy, and this is around that promise, right? So this is the promise of the dynamic import. So say we have AngularFire auth, and we call .signin with Google. It's going to call both of these. So a get is going to be the properties. So we could wait for auth, or the apply is when we call a method on a proxy, right? So a proxy will wrap the object. Apply will be called whenever a method is passed. So then we await the promise, right? We chain it. Promise, then it, and then we pass the arguments. So what this allows us to do is when you say AF auth, sign in with Google, and then new app provider, Google, but in those parens, when you say that, you don't have to worry as the end developer that that's a promise behind the scenes, right? You don't have to await AngularFire auth, then call auth.signin with Google. You can just say AngularFire auth.signin with Google. So this proxy wrapper right here hides the fact that we're actually dynamically importing the SDK and makes it look very similar when you're interacting with it. Finally, right? How do we build this promise? So the observable is an observable of the dynamic import and configuration. So we convert that to a promise. Then we get into it. If there's a return value and it's a function, we first need to bind that to something, or else we're going to get all kinds of bind issues. So we bind it and return it. So that is when you call sign in with auth, it will bind, return it, then apply the arguments that you passed. If it's a promise, then we're going to actually jump back into the node zone for the callback. This is especially important if you're using async await, because otherwise, I mentioned up top here, we're running outside the Angular zone. Otherwise, your yield is going to be outside of the Angular zone. So we want to return you to the Angular zone. We're only running outside because the JS SDK is agnostic and not built to work automatically in Angular. Finally, we just return the value. This is important for if it's a primitive value, if we're just looking at a property. So this is really, really, really dense code right here. But this proxy will promise wrap the dynamic import and then give us a similar SDK to the regular JS SDK. So how does it look, right? That was very complicated, very dense. How does it look? You just do how you normally do it, right? Like I mentioned. So auth sign in with pop-up, new auth Google app provider, and an auth.signout. And what's really cool here is auth is hiding the fact that it's dynamically imported and that it's doing all the zone wrapping and unwrapping and all that for you. And while this here is a lot of code and it's very dense, this is what allows us, the AngularFire maintainers, to give you a great Angular experience for an SDK that is not optimized for Angular. So, check this out, play around with it. If you develop other libraries that are agnostic and you want to play around with supporting them better for Angular developers, this might be something that you want to look into as proxy support increases along in browsers. So a couple shout outs here. I wouldn't have been able to do this if Angular hadn't bumped the new version of TypeScript. All this really much relies on TypeScript 3.7 and getting those superpowers that enables. We also have moved over to ng Packager. So ng Packager is doing all of our building. Before in AngularFire world, we had a very complex build script to maintain. And ng Packager is now dealing with all of our Angular package format concerns and Ivy compatibility. So if you develop a library, definitely use ng Packager. Final shout out, provided in any. Let's talk about this real quick. So what is provided in any? So basically, provided in any allows each one of our services to be isolated completely, and it's recreated every time it's dependency injected. It allows for much cleaner separation of concerns. So say you wanted to use AngularFire and you were using remote config on your SDK, right? So you're an SDK author, you're publishing something on NPM, and you want to use some of the Firebase features. A big problem before in AngularFire was these multi-tenant cases, right? Where you, the SDK author, you have your own config, you have your own AngularFire instance, and you want to point towards that. The end user, they might have one or more Firebase instances. Maybe they're sharding across different regions or, to scale better in a single region. So you're juggling, tons of different Angular apps. The provided in any means that every time you inject AngularFire auth, it's fresh. And when it looks for its configuration, it's looking for the nearest configuration to it. So if you're an SDK author, you just have to configure AngularFire once, then consume it, and that's completely isolated from the dependency injection tree of the end users. I'm sure I just confused all of you, but there's this really great article from Christian Kohler on Dev2. Look him up, look up the article on provided in any, and he'll walk through this new way of doing dependency injection in Angular and what you might get out of it. One last thing, the Firebase console, it's migrated to Angular 9 now. We're starting to do lazy loading dynamic imports. We're also a consumer of Firebase, right? There's a lot of work to do there, right? A lot of this is legacy code, has kind of been pulled along since the startup days. It's not as fast as we'd like it. That still loads way too many bytes of JavaScript. But I just want to say that the Angular 9 has been critical to the Firebase console modernizing and increasing its performance, and we're confident that the Angular team has our back with all of these improved tools. And huge shout out to the Angular community, huge shout out to the AngularFire community, and everyone helping with the betas and help ship all these new features. So go ahead, ng add at AngularFire version 6. It's cool stuff. If you're working with Firebase and Angular, it's going to make your experience really good. Thank you. If you want to follow me on Twitter, I'm at James Uriah. Yeah, thanks for joining. I guess at this point, we'll open up for a little bit of Q&A.
Thank you. So our guests can unmute themselves.
Can you hear me, guys?
Yes.
All right, I have like 2 questions. The first one is if I got everything right, if I have like Angular application, but I don't depend on Firebase for usage as a backend service, I can still use the screen service, performance service, and remote config in my applications thanks to the AngularFire, right?
Yeah, absolutely. So AngularFire and Firebase, it's a kind of modular. It's take the pieces that you want. You don't have to use Google Cloud. You don't have to use the real-time database. You can just pull in, Google Analytics support here. You can just pull in remote config. You can just pull those things that Google made that help you really scale, and then you can host it on Amazon or use MySQL and whatever you want. But we're not terribly opinionated there, and we want all these tools to work independently.
Great, that's amazing. I will definitely try it out. And my second question, because you're also part of the Firebase team and you mentioned the monetization of the Firebase, what are the near future plans for the platform? Because I've been part of some trainings where we firstly depended heavily on Kinview, which is another service that's from another company, whatever. But as the time passed, it starts to be only paid. You should have paid for it. And Firebase is right now our go-to solution for like teaching students to work with any kind of REST API. So what is the plan for monetization? Will it still get its free tier forever, or?
Yeah. So there's been some changes there. We got rid of the Blaze plan, and now the big thing is now just this pay-as-you-go plan, but it also has that free tier. The free tier is generous. One thing to note is if you do jump into the paid plan, right? Something that's going to be coming up more and more is there's probably going to be more abuse mitigations, right? Unfortunately for everyone, a lot of people like to, anytime there's free compute, they like to jump in there. They like to try to mine Bitcoin or something like that. So a mitigation against those abuse is a credit card requirement. So a lot of times to unlock, features that while otherwise are free, you do need some sort of billing method. So that's something to keep in mind. Our free tiers aren't changing. What may change is what capabilities you have if you are billingless, right? So no credit card, no billing account hooked up. Beyond that, we've actually been making some really great improvements to Firebase rules. So rules are how you make the Firestore real-time database and storage secure, despite the fact that there's no server in the middle, right? So how do you make a serverless solution secure? We've been pushing out some really great enhancements there. There's a couple blog posts and some more to come on all of the new Firebase rules improvements. And we've also been pushing very hard on our C++ and Unity story. So if you're a game developer, you're going to have a lot of improvements with Firebase, as well as just tightening up the core. I mentioned we are trying to make the console faster, better, stronger. That's going to continue to be a thing. Our integrations with Google Analytics and the rest of the Google platform is going to get stronger and a little bit more seamless. So keep an eye on our announcements. Keep an eye on our new event strategy. One of the things that has been hard is we didn't have a Google I/O this year, so we're sort of figuring out how to talk to you, the Firebase audience, and inform you of our new features. So keep an eye out. Definitely.
And what a great job, and I just want to applaud you on the great job that you're doing on the documentation, guys, because I've been using Firebase for more than a year. Let's say I'm checking from time to time, and currently the doctor on pretty high level, so keep up the good job. Thanks for the answers.
Definitely, thank you. I'll pass the good word on to the team. All right, any other questions before I pass it off to my colleague Minko? Going once, going twice, sold. Kick it off.
All right, so you hear me now, I guess, right? I'm mixing up the icons here.
Yep.
We got you.
All right, and you must be seeing my screen now, right?
I can see your screen.
Awesome. Okay, so I'll get started. So yes, my name is Minko Gechev. Also, first of all, здравейте всички. От тук нататък ще продължа на английски заради гостите ни от чужбина, т.е. чуждестранните ни гости, които не разбират български. And yeah, so James, that was greeting in Bulgarian. We're practicing
Excellent.
actually. Yeah, we're practicing actually in the office in San Francisco on the 5th floor. I'm sitting right in front of another Bulgarian who is from the TypeScript team. So yeah, sometime you should come and join us. All right, so yes, my name is Minko Gechev. I'm an engineer at the Angular team, and today I want to share with you what is the current state of the Angular's deployment, server-side rendering, and pre-rendering. As part of this story, I would want us to pretty much introduce a couple of updates, a couple of things that we have been working on at the Angular team, and I would want to introduce them into the context of the evolution of the web. And in the meantime, I'm also going to add some small portions of my personal story on how I got introduced to web development and how I got involved into all this. All right, so at the beginning in 1991, the first web application ever looked something like this. Actually, exactly like this. This is the first website ever deployed to the World Wide Web. And the World Wide Web is still a fascinating infrastructure, but really fascinating architecture in general, where we had different resources that were linked together through hyperlinks. It is fault tolerant. It is distributed. You have access, universal access to knowledge. And in general, it is quite flexible as well. At the same time, it didn't satisfy the requirements, the growing requirements of the business at long term. So a couple of developers came up with the idea for CGI, the Common Gateway Interface. The biggest problem with the original model was that all these websites were just static documents, and they were predefined at the time that you deployed them to production. From this moment on, you weren't able to interact with the user in any way, except just providing this document, and you weren't able to generate the document dynamically. So CGI allowed us to improve this. CGI just provided an interface in the web server, which allowed us to invoke an external program that can handle the user request and generate some dynamic content. Here is how a request processed by the Common Gateway Interface looks like. So the user is sending a request to a web server. The web server is delegating the execution of this, the handling of this request to an external program, which is fetching some data, let's say from a database or from the file system or some other different source. And we're returning a rendered content by this external program to the browser, to the client's browser, which is providing some context-dependent content. This way, we were able to execute this external program, and we were able to develop them in any language that we want to, as soon as this language somehow understands the Common Gateway Interface. And you can notice that I have this largest contentful paint marker here. The LCP stands for this largest contentful paint metric. That is a user-centric metric which estimates when a page is useful for the user. So this means that when the user sends a request over the network to the web server, and the web server gets the generated content from the external program and returns it to the browser, the user already sees useful content onto the page. So we have server-side rendering, and we are making our page useful pretty quickly. At the same time, CGI was serving the business for a lot of time, but it had one main drawback. Each interaction with the web page was requiring a complete page reload. So imagine just adding a tiny field, editing a tiny field on the web page, such as your username, let's say. This would require the web page to post a new request to the web server and an entire page reload, which wasn't quite convenient because this wasn't the same experience that users were used to by interacting with a desktop application on their laptops, on their computers back then. So together with this, the web evolved quite a lot. There were different APIs that were standardized, such as the iframe API, also the XML HTTP request API. And they were combined under the common hood of the AJAX technology, which allowed us to send requests in the background asynchronously to the server without actually reloading the page. So this way we were able to update just tiny portions onto the screen and handle user requests without requiring the page to be reloaded completely. With AJAX, we changed the loading model a little bit. Now the user is still sending a request through the browser to a web server that is delegating this like request handling to an external program, which could be any program. Like the LAMP stack was really popular back then, Linux, Apache, what was that? PHP and MySQL. So we were still getting the largest contentful paint pretty early on. But right after that, we're also downloading a bunch of JavaScripts that were enhancing the page behavior. They were adding different event listeners to DOM elements, and they were able to update only tiny portions of the web page without requiring a complete page reload. Right after that, they were able to interact with the external service by using AJAX. And that was around the time when I first got introduced to web development, actually. I read this heavy read. That was actually the authentic cover. Разработване проекти за web, PHP, MySQL. I spent a lot of time reading through this book. It was 500 or 600 pages. And I developed one of my first websites about the school, about like my high school originally. And right after that, I generalized it as a CMS system and developed this website for the local, for the Balkans, for this mountain chain around the region where I grew up. And I even presented this in front of an audience consisting of these two people. That was a national competition in IT technologies. And I was really excited about presenting this. That was my work that I developed in the course of a couple of months. And this helped me get into university as well. The next year, actually the same year, Backbone went out. It was officially released. I believe this happened in 2008. But 2008 and 2009, AngularJS was officially released as well. AngularJS was the previous framework coming from the Angular team. And these two technologies, Angular and Backbone, they gave a good structure to web application development for the first time on the client side. Before that, we had different ways to create client-side experiences with a bunch of jQuery scripts. We also had some patterns coming from the backend mostly, and from Smalltalk for organizing our applications in MVC fashion. But Backbone and AngularJS, they were the first attempts to create really rich user interfaces and experiences only with JavaScript. So then we changed the way that we were loading applications quite a lot. First, we're sending requests to a web server again, which is delivering just a simple HTML page. And this simple HTML page is referencing a lot of different script tags. But at this point on, we're just seeing a loading indicator because we're entirely rendering the page now into the context of the browser. Right after that, once we download the scripts, we start executing them. And finally, we're making the page interactive, and also we're providing this largest contentful paint. So see how much time it passed until the user saw like anything meaningful onto the screen. That's definitely not a great user experience. Waiting for a couple of seconds or even minutes, depends really on your network connection in order to deliver all these JavaScript files and let them render the page and make it interactive. And the only thing that developers can do in order to improve this loading experience is to reduce the number of bytes of JavaScript that they're sending to the user's browser. This is to a huge extent dependent on the framework that you're using as well. So in the Angular team, we put a lot of effort in order to make sure that your applications are as small as possible. And we're still working in this direction. In fact, yesterday, I was talking to Webpack and we were discussing how we can improve tree shaking for CommonJS. We spent a lot of time in optimizing the tree shaking in Angular itself. We made sure that the framework's runtime is as small as possible, that we're generating the smallest amount of code for your templates as possible. And although we still have a lot of long way to go, at a certain point we had the joke that by version 5.4, we're going to make the framework so small that your bundle size is going to get negative just the moment when you introduce Angular into your application. And that's obviously not possible. And I don't know how you define a negative bundle size, but at a certain point, you just can't get any smaller in terms of bundle size, right? You still need to deliver some features to the user. So you need to ship some JavaScript. I put this super insightful quote here. So that's why a lot of people around the era when Node.js was becoming really powerful, and we were really excited that we were able to run JavaScript applications full stack, including on the server, they started experimenting with the idea for server-side rendering, or more like client-side rendering in Node.js environment. With this server-side rendering paradigm, the things went they look pretty much the same as they were with CGI plus Ajax, with the main difference that we have much more code reuse, because we're using the same source code that we're client-side rendering our application onto the back end. So this must have been somewhere around 2013, 2014, when was also my very first international talk. I gave it on NG Vegas. So I spent about 10,000 kilometers in the aircraft flying from Sofia to Vegas to represent my research on how we can improve the performance of our AngularJS applications with immutable data structures. And on this event, I was extremely nervous. I actually gave my talk, and right after that, I went to my hotel room, and I didn't get out until the late afternoon because that's how nervous I was. But at this event, I met these guys right here. Actually, I met only Patrick, the guy on the left. Together with, these are Patrick and Jeff, who developed Angular Universal. They in fact presented it for the first time about 2 months after NG Vegas. And that was the first server-side rendering experience for Angular in general. So they presented Angular Universal on Angular EU. And since then, the entire Angular community and the Angular team has been really heavily collaborating in order to make this Angular server-side rendering a robust industrial solution that is now used by a lot of different companies around the world, including Crunchbase. So some of the drawbacks of the server-side rendering experience with Angular Universal that we often hear about, though, are that the change refresh time is not ideal. In order to make a change in your application, which impacts both your client and the server, you would have to build your client, you would have to build your server as well, and right after that, you would have to run your development server for Angular Universal. Another painful experience that we often hear about is the deployment. Although there are well-defined paths on how you can deploy your Angular applications with server-side rendering support to production, there are still a lot of boilerplate. And well, this could be definitely improved with our tooling. So first, I'm going to talk about the change refresh time. In version 9, we introduced the Serve SSR builder for the Angular CLI, which allows you to do something like ng-serve, but this time for an Angular Universal application. So we'll be watching the file system, and when we detect a change in any of the files that we're looking at, we're going to build your client, your server, parallel, and we're also going to refresh your browser while running a development server in the meantime. So this is not a complete replacement of ng-serve, but it still improves your development experience to a huge extent. It is not a complete replacement of ng-serve, mostly because it takes longer to rebuild to reflect the changes, since we're building both your client and your server, and this wouldn't be as fast as ng-serve. But when you're working on Angular Universal applications, when you're making changes mostly on the server, this is quite a good alternative to rebuilding everything manually. In order to take advantage of this feature, you should just run ng update, ng universal express engine. So as a disclaimer, in version 9, we did a lot of changes, especially on the universal side. There is a chance that your update experience for Angular Universal in particular is not as smooth as this. There are a lot of articles online, and also we introduced some details in our migration guide on Angular.io. So if this doesn't work out, as I have said on this slide, just make sure that you look at the additional resources. So this is another example of how we collaborated with community. Here, Alan collaborated with Manfred from community, who is one of our committed collaborators, in order to develop this feature. And that's actually the one of the main strengths of open source that I'm really excited about. How we can combine forces in order to deliver solutions that work for everyone. Anyway, now let us talk about deployment. This is another effort that we work in collaboration, this time between the Firebase and the Angular team. We developed a ng-deploy experience for Angular universal applications to Firebase functions. Now let me show you how, by using just 2 commands, you'll be able to take your Angular universal application, which uses version 9 or above, and deploy it to a Firebase function. So this here is an Angular universal application. Now I should just run ng-add AngularFire. Here I'm using the Canary version. At the moment when I was recording this video, the deployment schematics were still under Canary. So notice how the ng-add schematics for AngularFire, they scanned our project. They detected that this is an Angular universal application, and they're suggesting us to deploy it as a Firebase function. Here we can just agree with the suggestion. We can type yes. And this is going to start an installation process of Angular Universal and a couple of other Firebase dependencies. After that, we can select the Firebase project, and we can just run ng-deploy. When you run ng-deploy, first we're going to build the application, both the client and the server. And right after that, we're going to start deploying your static assets to Firebase hosting. So all your static assets are going to go to Firebase hosting. So you're going to provide them to your users from a static CDN. And at the same time, we're going to deploy your server as a Firebase function. Right after you click on this URL that we give you, you're going to see that you have a server-side rendered application with just 2 commands in this case. When talking about server-side rendering and deployment, we often hit one potential place for improvement. So very often, most of the pages that we're server-side rendering, they do not change their content much. So we're rendering the same page and getting the same result all over again. A lot of people are fixing this by using caching. So with caching, they're caching the response based on the request of the user. And once they receive a request which has similar shape, they're just returning the result directly from the cache. Although this is a fine solution, at the same time, it also introduces much more complexity and much more like different moving parts to think about when we're deploying our Angular Universal application. It also adds some runtime overhead. The first user who is supposed to open this page, they're not going to get the result directly from the cache. Instead, they'll have to go to the server. The server will have to render this page, and right after it, we're going to push it into the cache, and we're going to finally deliver it to the client, which is far from ideal. Since the content of certain pages, they don't change, like this content doesn't change at all, we can just run Angular Universal against them, and we can pre-render them as part of our build process. So see how we discussed so far how we can perform client-side rendering entirely in the browser. We can perform also server-side rendering, like on the server. It is pretty much the same client-side rendering, but this time we're performing it at request time. We can also perform this client-side rendering as part of our build process. Well, when we're building the application, we're going to run Angular Universal, which is going to perform this client-side rendering at build time. And this is what pre-rendering is. So with pre-rendering, we introduced a new builder in Angular Universal version 9. We spent some time in order to optimize this experience as well. So with ng-add, ng-universal, express engine, and right after that running ng-run, the name of your project pre-render, we're going to detect all the pages in your application which do not have any route parameters, and we're going to render them as part of your build process. Since we wanted to make this as fast as possible, we spent some time optimizing it, as I mentioned. So when you run ng-run app pre-render, we're going to first build both your client and your server, and right after that, we're going to run this pre-rendering experience. It currently runs with about 400 pages per second, because we are running the individual pre-rendering. We're pre-rendering the individual pages in different processes of your machine. Some folks from community, they experimented with even larger pages. So here, for example, Steve ran Angular Universal pre-rendering on top of a web app which has 10,000 pages, and his result was in about 75 seconds. And I'm sure that about 60 of these seconds were spent in building the production assets for his app. So my guess is that the pre-rendering took about 15 seconds in total. So I'll talk about this pre-rendering feature of the Angular Universal package that we have. And this brings us to even better support for the Jamstack. The Jamstack is this paradigm. Like every 10 years, I guess, we have different stacks. Now we have the Jamstack. The Jamstack is a way to build performant applications in a simpler way. We can use JavaScript, APIs, and markup in order to build fast applications, since they're just composed of some simple markup and a couple of lines of JavaScript. And we can directly push them to a CDN because they don't have any server-side logic associated with them. So with Angular Universal, we can already do that. But folks from community, they already developed a static site generator for Angular as well, called Scully, which takes a different pre-rendering strategy compared to Angular Universal. Scully is a way to build static websites, and it also has a large plugin infrastructure. So at build time, you can fetch content from different sources. You can fetch content, for example, from WordPress, or even from your custom source if you develop a plugin for yourself. So in this talk, I mentioned collaboration and community many times. That's actually one of the main reasons that I'm pursuing a career in the open source world in general. Like this constant collaboration between different people with different backgrounds, that's super empowering. And I'm really happy that together we were able to build such awesome solutions. That was it. Thank you. I'll be happy to answer some of your questions, or most of them. Yes, any questions?
There is one question about recording of the session. It is not direct for the content. Yes, it is recorded, and we will share it.
And all our slides are already online, I guess. So I can share them as well. Here is, I'll just post a link to my slides in the chat. All right, I guess if there are no other questions, I'll pass it to Misho.
Well, thank you very much for this awesome session. It is really very useful, and hope to see you again at some of events, and later this year, probably in some events on site in Bulgaria.
Sounds great. Oh, there is one more question for James.
Yes. So James, I want to ask you about the future planning for some of the features of Firebase. So when I tried to develop some small apps or whatever, I found out that you're not able to query stuff by strings, and if you are depending, I mean, like the demo is using a third-party service, which is Agolia, and it says you can implement it by yourself. But my point is, why is something saw like frequently used functionality not developed by the Firebase team and like search by string. And I saw a lot of very early solutions for that in Stack Overflow, and I was like, why this is like something that you should have?
Yeah, definitely. You know, definitely full text searching is a question that we get often. We do steer a lot of people towards services like Algolia. Now, the Firestore team does know that you know, full text search is something they'd like to do. They would like to do it. However, right, this is a new database, right? We've built a database. The time frames on adding new features to databases, unfortunately, since you know this is a globally replicated, scaling, very, very complex machine. Those time frames are not measured in weeks or sprints. You know, oftentimes adding a large new feature like full text searching, to be frank, will be measured in years, right? The team is very focused on making sure that the experience with the current feature set is great. It's not leaving anyone behind. And that everything, all the features that we have now scale with time. And just, if people aren't familiar, one of the great things that Firestore gives you is that the size of your database, as your database grows, that has no effect on your query performance. So one of the problems with large databases, right, is as your database grows in size, the same query that you were making before that was performant gets slower over time as your database increases and the indexes get more complex. Firebase's performance guarantees are that as the database grows, that you know, query that was performant before is still going to be performant. It's completely independent from the size of your database. And if people know cap theorem and all that computer sciencey stuff, that's actually a very, very hard guarantee to give. And it's something that we have to be mindful whenever we add new features to Firebase specifically. Now, the integration with Algolia and providers like that, right now it seems a little hacky. You have to spin up a cloud function, replicate things. This is one of those things where I'm hoping that Firebase extensions are add-ons to Firebase that right now they're created by Firebase team, or they're created by, you know, third parties that we've worked with, partners. But in the future, we're actually opening this up to the community. So we're hoping that, you know, maybe you can't give the same guarantee for performance, but maybe someone in the community could build a full text search capability in Firestore and then publish it as a Firebase extension. And that will have a great App Store experience. You know, there's a view where you can see all the extensions and you can click add. So do check out Firebase extensions. We're hoping that the community is going to build more. You know, I know Firebase DevRel and the software engineers are building more extensions with time. And that's probably where capabilities that aren't in the native platform, like full text search, that's where that's going to be living long term.
It seems we have no more questions.
All right, great. Well, you can find Minko and I on Twitter. You know, my DMs are open, so feel free to, you know, shoot me over questions.
Thank you very much.
Cheers.